All right, ladies and gentlemen. So here, hopefully, we're going to get a little bit of payoff about why we put all this time into studying the unit circle and learning how to evaluate trig functions. So here's an example of what a trig function might model. In this case, it's the temperature outside of the house. And we're going to start at a nice warm 80 degrees as I record this video. It's still pretty cold. I'm looking forward to these spring days. You can imagine the temperature outside the house, especially on like a nice warm day where the sun's out, kind of fluctuates, right? So it starts kind of cooler, warms up as the sun goes out, and then cools off again as the sun goes down, and then warms up again the next day to roughly the same temperature. And then the cycle kind of repeats, right? So that's the type of function we're going to get here. That's why these things are useful. And the goal here is kind of develop the understanding of like, why does this cycle happen? And how do we get this shape of a curve, right, from our, in this case, a cosine function? To do that, we're going to start to develop our curve here at 3 different points. We have t equals 0, 12, and 24 hours. And you can do this on your calculator, make sure you're in radians. But the best understanding is going to come from doing it by hand. So I've written out this function for you, and then all we have to do is every time we had a t, we're going to replace it with our value. So here we have t equals 0. Here we have t equals 12. Here we have t equals 24. And then I'm just going to simplify. 0 over 12 is 0. Okay, so now I need to evaluate my cosine. And to do that, I might draw a little sketch of a unit circle. And I have this point 0 for cosine of 0. Remember, cosine is the x values, right? So the points are always cosine, comma sine. So at 0, this would be the point 1, comma 0. So this whole thing evaluates to 1, right? So it would become 80 minus 10 times 1. And then here, cosine of pi, well, that's over here. That would be the point negative 1, comma 0. So this whole thing evaluates to negative 1. And then 2 pi, well, 2 pi is all the way around. So we're back here. That's 80 minus 10 times 1. So we pick some nice easy points to start with. And then I can just evaluate here. So here I get 70 degrees. Here, it's going to be real warm. I get 90 degrees. That'll be at noon, so that makes sense. And then here, the next day at midnight, I guess, I get again 70 degrees. Okay? So that gives us some points we can start to plug in. So we had t equals 0 was 70. We had t equals 12 was 90. And we had t equals 24 was 70 again. Let's get some points in the middle. So let's do, I don't know, we'll do t equals 4. So let's do f of 4. And that would be, of course, 80 minus 10 cosine 4 pi over 12, which would equal, and then again I can sketch my unit circle. Pi over 3 is a 60-degree angle, and here's where it pays off to have this down really well, right? So the cosine, the x value here is 1/2, and then of course the y value would be root 3 over 2. But we want that x value, so we get 80 minus 10, and then that whole thing evaluates to 1/2. 10 times 1/2 is 5, so we get 75 here. And notice we start to get like this little bit of symmetry. So I can just kind of see that if I did f of 20, I would get that same value, right? And that's because f of 20 would be down here on my unit circle with the same x value, right? And we could even do one more value here. We could do, let's see, it looks like f of 8 would fill in my curve nicely, right? So, and notice 2 pi over 3 is that kind of same place on the unit circle, but negative, right? So that would be negative 1/2 and root 3 over 2. And then I'm adding that 5 this time now, so I get 85 degrees. Right, so that would be for 8, and notice then by symmetry, I'd have that same kind of value here. And here's my nice curve. I made it kind of ugly. We'll try one more time. There we go. So here's f of t. And notice it took a lot of work to fill that in, but the more fluent you are with the unit circle, the faster it goes. And then here we have some properties we can highlight. The average temperature, notice this whole graph kind of oscillates up and down by 80 degrees. So this is our average. That's sometimes called the midline of the curve. And then describe what the model predicts would happen on day 2. Well, day 2 would just be another lap around our unit circle, right? So what we would get is another cycle of the same y values. And if you don't believe me, you can use your calculator to evaluate some values in between. So for example, let's see, 36 hours would be the same as 12 hours. You can double check that we get the same values there. Okay. So here is how we get what is called a sinusoidal curve. Now, let's dive into some properties. So I printed the unit circle here for our convenience. We're just going to plot the easy points. So remember, sine is our y value. Sine of 0 is 0. That's here. Sine of pi over 2 is 1, right? And in between it would be pi over 4, but root 2 over 2 is kind of hard to plot. I don't know where it is. So we'll skip that one. For pi, my sine is 0 again. 3 pi over 2 is down here. I get negative 1. And then 2 pi is 0. For my negatives, we imagine ourselves going the opposite way on the unit circle, so clockwise. Negative pi over 2 would be the same as 3 pi over 2, so that gives me a negative 1. Negative pi is the same as pi, so that gives me a 0. And then, obviously, the pattern here repeats, so we're at 1 and 0, right? And then when I draw my curve, I get my nice sine wave that I'm expecting. Now it's really ugly. That one's better. And then cosine, remember, is my x value. So as I look at my unit circle, cosine of 0 is 1. So that is the difference between the curves. Cosine of 0 is 1. Pi over 2 is 0. Pi is negative 1. And I'm just walking around the unit circle again. On the other side, we start with a 0, and then negative pi is a negative. Right, and then 3 pi over 2 is positive, and we're back to, 3 pi over 2 is 0, and then we're back to positive for negative 2 pi. So there's my cosine curve. Again, we'll connect all the dots. Okay, so there are sinusoidal functions. Notice they're the same shape, just shifted. So the way we tell the difference between the two is based on the y-intercept, but other than that, they're just translated horizontally. Okay. We have a general form, sort of like a y equals mx plus b of these equations. And your mission, and you'll be able to figure this out based on your knowledge of translations and examples you see in the delta math, your mission is to figure out what a, b, and c does to our curve.